measurements. In this entire session, I'm taking the measurement subject. I'll try to complete the entire subject revision, whatever the important topics are there, and how to complete entire topic in very shortest time. I'm going to cover everything. I'll try to cover almost all chapters. Here in this measurement subject, and before starting the entire syllabus, small idea I'm giving. By the time other people will join, right? Here in this measurement subject, basically gate electrical paper. In gate electrical paper, 3 to 4 marks, as you know always, right? Already you know, gate electrical paper 3 to 4 marks is general weightage. In the same way, gate instrumentation paper also the same subject is there, right? And here around 10 to 12 marks. Therefore, in the class also I told you, electrical people should concentrate on this subject for both reasons. One is conceptually, this subject is very, very important as it is a core subject, and not only electrical paper, you are also eligible to write instrumentation paper as a second paper. Therefore, subject is same, syllabus is same, everything is same, but weightage is approximately 10 to 12 marks. That's why you need to concentrate on this subject for sure. And mainly people are asking that, sir, in the electrical paper weightage is very less, can we neglect the subject? No, this entire measurement subject is core subject as well as scoring subject. Suppose if you get, right, 4 marks as the weightage in the exam, for example, right, you will be getting all 4 out of 4. In that way, the questions will be given. That's what is called as scoring subject also. That's why no one is supposed to leave this subject, because even though it is having 3 to 4 marks weightage in the gate electrical paper, you should not leave this subject because it is scoring subject. If you are getting 3 marks, you will get 3 marks for sure. If you are getting 4 marks, you will get 4 marks for sure. In that way only the questions will be given. So that's why don't neglect it. And in this entire today's session, I'll try to cover almost all topics. Concept I'll revise and a few questions also will try to take. So let us start the topics like, so this is the total discussion I'm taking. First, I'm starting with a topic called error analysis. I'm talking about error analysis. This is the first chapter generally, right? Sir, in our entire measurement, the error word plays the major role. In the entire measurement subject, the error word plays the major role. Without this error, we cannot complete any topic like PMMC instrument or EMI or EMMC, measurement of power. Whatever the topic you take, we will be asking about, we will be talking about what is the error. Is the error less or is the error more? In that way, we are going to take. That's why concentrate more on this word. Sir, what is the error meaning? What is the error meaning? Sir, generally, if one circuit is there, for example, one circuit or one network I'm taking, okay, I want to measure the current in this circuit. Every one of you know that in order to measure the current, ammeter will be used, and that ammeter must be connected in series. So therefore, I'm connecting the ammeter in series. Okay, right. The point here is, sir, in this circuit, assume that, we don't know, but assume that 4 amperes of current is flowing. For example, if we are using the ammeter in the circuit, do we have any chance of getting same 4 amperes value in the ammeter? Definitely no. Why, sir? Practically, some errors will be there, some losses will be there, some deviations will be there. That's why assume that this ammeter is showing approximately 3.9 amperes, for example. Approximately 3.9 amperes, for example. Okay, so therefore, sir, this is the value called as measured value. This is the value called as true value. Therefore, in the practical orientation, in the practical approach, whatever the value shown by the device will not be exactly equal to the value which is present in the system. Therefore, Between these two, difference will be there. That difference is called as, which one? Error. That's why I told in the class, error is equal to, what is the formula? AM minus AT. The measured value minus true value is called as error. That's why the difference between measured value and true value is called as error. This is the basic definition of error. And after that, in the practical approach, AM may be greater than 80 or AM may be less than 80. We don't know. That depends on the practical system. So therefore, assume that we are measuring something. In that particular application, if measured value is greater than true value, or if measured value is less than true value, for example, under this condition, what is the error nature? What is error formula? AM minus 80. So, if AM is greater than 80, then error will be positive. And if AM is less than 80, error is negative. So, therefore, in the practical approach, the error may be positive or error may be negative. Therefore, simply we can write error is either positive or negative in the practical approach. That depends on the given data. It may be positive, it may be negative. But, sir, practically speaking, can we have any chance of getting error as 0? Definitely no. Why, sir? In order to get error as 0, what is that? Measured value must be equal to true value. Is it possible? Not at all. That's why practically error will be either positive or negative for sure. Okay. After that, sir, errors are of two types. One is static error. And second one is dynamic error. Types of errors basically static error and dynamic error. Guys, what is a static error formula or static error definition? The error which is constant, or in the simple way, error which is independent of time, error which will not vary with respect to time. So simply error which is a constant, that is called as static error. What is this? Error which is variable. So that's why in the simple way, what we can write now, it is a constant error. It is a constant error, and this is a variable error. Constant error and this is variable error. Okay, the point here is, sir, what is a formula of static error? What is a formula of dynamic error? Even in the class also, in the starting stages, you got confused. Okay, static error formula, dynamic error formula, different in that way you thought it. No, the point here is, the static error is represented with epsilon naught or delta A we can write. Delta A. Why, sir? Change in A from measured to true, like that I am taking the letter A. But dynamic error is simply we can write it as epsilon. Okay, now, sir, it is also an error. Don't forget this. People are thinking that, sir, dynamic error means the variable error. Okay, and by taking the word as variable, people are changing the formula. People are saying that some AM minus 80 by something, or AM minus 80 into something, like that, some different formula they are giving. Why? By thinking that dynamic error means variable error, so it should vary. Means basic formula is AM minus 80, therefore AM minus 80 will not be there. In that way they are thinking. No guys, even in the class also I told you, static error is an error. At the same time, dynamic error is also an error, is it not? Static error is also an error, dynamic error is also an error. So that's why, first, what is the error formula? AM minus 80. What is the error formula? AM minus 80. Don't forget to mention this. What is it? Static error is an error, so error formula is AM minus 80. Dynamic error is an error. Error formula is AM minus 80. After that, let us analyze. What is that? Sir, this error is static. What do you mean by that? Suppose it is an instrument. I am measuring now. it is showing plus 0.4 as error now. After some time if I measure, same plus 0.4. Even after some time if I measure, it is showing same plus 0.4. Therefore, what is this plus 0.4? Error. What is this nature? Error is constant. That's why this AM minus 80 value is constant. AM minus 80 value is constant. Okay, here AM minus 80 value is variable. What does it mean? If you measure the error now, it is showing plus 0.5. After some time, plus 0.7. After some other time, plus 1 or minus 1. In that case, we can say it is an error which is varying. So, therefore, error formula will be AM minus 80 only, but its value is variable, but its value is constant. Based on that, we can say static and dynamic. Clear? So, you have to understand simple logic. For example, in our electrical engineering, if we say variable power is there. For example, I am saying variable power, nothing but power is variable. By taking this, can you change the formula? Normal formula of power is V into I, but it is a variable power. Therefore, I will change the formula of power. No, that's why formula of power is same. If the power value is a constant power. If the value of power is variable, then it is called as variable power. Same concept here. That's why hold this entire point clearly. Static error and dynamic error formula is same. This is a basic idea regarding error. Here we are having one error called relative static error. Relative static error. Relative static error. So, what is this relative static error? It is, in the simple way, we can call this as relative error. Sometimes in the examination they are giving as relative error, right? In the simple way we can write RSE. Simple we can write RSE. Okay. So, what is its formula? Sir, error is represented with epsilon r, and a relative static error, no, so simply what is that? Epsilon r. Guys, the relative static error itself is defined with respect to, expressed with respect to which value? True value. So, therefore, what is that? This is with respect to which value? True value. Nothing but an error expressed with respect to, what is that? Static error expressed with respect to, or static error related with respect to true value is called as which one? Relative static error. Now tell me, what is the static error we have taken? Static error formula AM minus 80. So I am taking AM minus 80. Sir, static error is expressed with respect to. Static error is related with respect to. Static error is expressed with respect to, or static error is related with respect to which value? True value. AM minus 80 by 80. Suppose if you want to get percentage, simply we have to take into 100. If you are taking AM minus 80 by 80 into 100, that will become percentage error. Now, this percentage error is also called as, remember guys, anyone? Try to answer those who attended the class. This relative static error, other name, right? The other name of this is percentage limiting error. Percentage limiting error, right? That's why in the examination they may be giving the word as percentage relative static error, or relative static error, or relative error, or sometimes percentage limiting error also may be given. So, percentage limiting error is other name of relative static error. And sir, this error is which error guys? Variable error. This error is variable error. Sir, why variable error? Means, for example, I am taking one instrument. This is 0 to 10 ampere instrument, for example. 0 to 10 ampere instrument. Sir, if this instrument is given to us, we can operate this at 2 amperes of supply. according to our requirement. Suppose some other operator requirement may be around 3, they can operate around 3. They can operate around 5, they can operate around 8 also. Why, sir? This is the instrument designed for 0 to 10. So therefore, from 0 to 10, any value we can use it. So that's why from 0 to 10, we can have any values. Assume that my requirement is this, your requirement is this, and some other people requirement is this. Now tell me, as far as the instrument is concerned, be clear with this point. As far as the instrument is concerned, these values are fixed always. It depends on the corresponding operator requirement. Means definitely I am using my requirement, you are using your requirement, something else. That's why as far as the instrument is concerned, these values may be variable or should be constant. Tell me guys, if I'm talking about only instrument, I am using for my requirement, you are using for other requirement, some other people are using for their requirement, like that. So all these values should be variable or constant. Definitely variable. Now tell me, sir, percentage limiting error is equal to, what is the formula? AM minus 80 by 80 into 100. Now try to understand this point. What is the name of the error? Static error. Therefore, what is this? Numerator is static, numerator is constant. Numerator is constant, but this value keep on varying with respect to the operator requirement. So therefore, numerator is constant, but denominator is variable. So therefore, automatically ratio is variable. Yes or no? Therefore, this percentage limiting error is called as variable error. But in the class, I gave the complete proof. But in the revision session, I am giving the simple conclusion model. In the short fashion, I am giving. So therefore, in this AM minus 80 is anyway constant because it is a static error. But a true value will be keep on getting varied based on the operator requirement. Therefore, this is constant, this is variable. Therefore, ratio becomes variable. That's why it is called as variable error. But for this, complete proof I gave you in the class. Clear? So this is the total thing regarding percentage limiting error. Okay. Now, there are different types of characteristics we have. Few are static characteristics and few are dynamic characteristics. I am going to brush up all those characteristics in the shortest way. Sir, I am giving the list first. The characteristics are accuracy, precision, drift, linearity, sensitivity, resolution, dead time and dead zone. Dead time and dead zone. So these are the corresponding things. And what is the other value here? Accuracy, precision, drift, and one more is also there. I have not given that. Now tell me, what is the other characteristic, everyone? I gave you 7, but in the class I told you 8. Which one? Hysteresis. Very good. Hysteresis. Now, other characteristics are also there. What are those other characteristics? Dynamic, we can say. What are the dynamic characteristics, guys? Speed of response, measuring lag, and fidelity, we can say. Fidelity. So these are the characteristics we have. All these are static, we can say. These are dynamic, we can say. Now tell me, what is accuracy? Guys, try to understand. It is a revision session. It's not possible to take entire discussion in detail, as you know. So I'm brushing up. What is accuracy? Guys, tell me, what is accuracy? The accuracy meaning, in the shortest way I'm giving, accuracy, right? Measured value measured value close to true value. If measured value is close to true value, then that nature, that phenomenon is called as accuracy. Or simply we can say, in any instrument, if measured value is close to true value, that instrument is called as accurate instrument in the simplest way. Okay. Suppose, if I'm talking about precision, guys, what is precision? Different ways I gave in the class. Precision means mostly repeated or mostly reproduced value is called as precise value, I told you. And one more also I gave you in the experimental way. What is it? Measured values are close to each other. If measured values are close to each other, then that phenomenon is called as precision. In the class also I told you, in the examination they will be using the close and close word, but don't get confused, complete statement must be read compulsory. Why, sir? Here also close is there, here also close is there. Here measured value is there, here also measured value. But measured value is close to true value, then that is called as accuracy. Measured values are close to each other. Measured value 1, measured value 2, measured value 3. For example, all these three are close with each other, then that phenomenon is called as precision. And third one is drift. What is drift? It is also a deviation, but this is a deviation in characteristics plots. So therefore, what we can say, deviation in characteristics plots, we can say. Whenever we are plotting the graphs, if we are getting the deviation, that deviation is called as drift, we can say. Next, in this, how many types of drifts are there? Remember, is it zero drift, span drift, zonal drift. Very simple way I am revising. Zero drift means change in the drift is zero. Span drift means drift value keep on getting increased towards the corresponding full value, we can say. And zonal drift means it is the error or drift occurs in a particular area. That is called zero, span and zonal drifts correspondingly. And then what about hysteresis? Right? The hysteresis meaning itself is, it is exhibiting different properties during magnetization and demagnetization, and whatever the loop we are getting due to that, that loop is called as hysteresis loop. Whatever the loss we are getting due to that, hysteresis loss. Whatever the error we are getting in our measurement language, error we say, that error is called as hysteresis error. That's why simply it is a magnetic phenomenon which will present in the instruments for sure. Right? Next, linearity. What is linearity? Right? Output is proportional to input, generally we can say, or strictly speaking, delta output, that is small change in output, should be equal to small change in input, then it is called as simply the system is a linear system. Okay, sir, this linear scale is available in which device? PMMC, permanent magnet moving coil instrument. Which scale is there? Linear scale is there. If you are talking about linear, immediately we need to talk about non-linearity also. Non-linear or non-linearity. What is non-linearity? Definitely this is not equal or zigzagly changing or correspondingly parabolic system or rectangular hyperbola, anything you take, that is simply non-linear system. But how do you find out percentage non-linearity? Remember the formula? I told you this was the previous question. The question was present from this topic in the IN paper, I told you. We have done question in the class also. What is the formula? maximum deviation of obtained line, that is non-linear line from the ideal line, we can say. Maximum deviation of obtained line from the ideal line divided by which value? True value. Divided by which value? True value. But we can express this corresponding percentage non-linearity with respect to two cases. What is that? With respect to true value we can express, or numerator will be same, but in the denominator full scale value into 100. In the examination they will be asking like, find out the percentage non-linearity with respect to true value, find out the percentage non-linearity with respect to full scale value. In that way they will be asking, right? Next one, sensitivity. What is sensitivity formula? Sensitivity can be expressed in both ways. One is experimental approach, that is delta output and delta input. Other one is based on the full scale deflection. So therefore, delta output by delta input, and one more formula, 1 by IFSD. 1 by IFSD. I told you, whether you take voltmeter or ammeter, anything, generally we define always with respect to 1 by IFSD only. So this is the formula of corresponding sensitivity. The sensitivity other name of sensitivity is figure of merit. Other name of sensitivity is figure of merit. In the examination, they may be giving the word like find out the figure of merit or simply find out the sensitivity. But one more word is there, reciprocal of sensitivity. Reciprocal of sensitivity. What is the reciprocal of sensitivity? What is remembered? Deflection factor. Deflection factor is equal to inverse sensitivity. Inverse sensitivity is equal to, simply reverse the formula. What is it? Delta input by delta output, or 1 by IFSD. Simply we can write IFSD. This is all about sensitivity. And resolution. What is resolution formula? Resolution is defined as a ratio. Which one? Full scale value by number of divisions. Full scale value by number of divisions. Right? And resolution, what we expect always, it should be as good as possible. So therefore, resolution must be always better than the system. We prefer that system. And sir, in this, the resolution will be defined only for linear scale system, only for non-linear scale system, or both? Try to answer. The resolution is defined in which type of scale instrument? Resolution is defined for which type of instrument? Only linear or only non-linear, or both are possible? This is only for linear scale instruments. In the non-linear scale instruments, we cannot define the resolution, we cannot find out the resolution value. That's why it is defined, or it is defined in only in linear scale instrument, not non-linear at all. Few people gave the both. I think you might have forgotten the topic, right? If it is a non-linear, we cannot find out the resolution value. That's why resolution is defined only in linear scale instruments. And next one is dead time and dead zone. So what is dead time and dead zone? It is a minimum time required to respond. It is a minimum input required to respond. What is the meaning of that? For example, this is a time axis or input axis. This is correspondingly output. Okay, at 0 time, we have given the input, but output is not there. Input is given, output is not there. And input is given for some time, still output is not there. Assume that After some time, corresponding response like this or something linear, non-linear will be there. Now tell me, this is the minimum time required to respond, to get the response. Therefore, this is the time called as dead time, we can say. In the simple way, we can say wasted time. Wasted time, we can say in the simplest. That's why this is a minimum time required to get the response from the instrument. So that time is called as a dead time. And if I'm talking about input, this is the minimum input. This is the minimum input required to have the corresponding response. Therefore, this portion is called as dead time, or this portion is called as dead zone. Both are interdependent. Why, sir? Time taken by the dead zone is dead time. Input wasted in the dead time is called a dead zone. In the vice versa, we can explain. This is called complete thing regarding dead time and dead zone. And next one is dynamic characteristic, we can say. Speed of response. Speed of response. Guys, the speed of response must be as high as possible or as low as possible. The speed of response must be as high as possible or as low as possible. Definitely as high as possible. So therefore, it must be expected to be as high as possible. And here, measuring lag. Measuring lag. I told you in the class, and we spent a lot of time on this topic. Measuring lag means lagging in the measurement. Lagging in the measurement means, can we say indirectly, it is a delay in the measurement? Yes. So therefore, simply this is nothing but delay. Guys, this is delay, okay, but this is delay provided or happening means this is the delay provided. This is the delay provided, nothing but we are nothing but manufacturer is supposed to provide this delay circuit compulsory, delay unit compulsory. And I told you, at this point I told you, in the electronic measurements, in the CRO chapter, right, in the corresponding block diagram and operation topic, delay unit will be there. Based on the delay unit only, proper operation of CRO will be there, I told you. And you will study this in the CRO topic, I told you on that day. By this time, entire syllabus is completed. No, you should be able to recollect that. And that too, recently, few years back, in the gate paper only, based on the delay time, based on the delay unit, one numerical question was given. So kindly focus more on this. Okay, sir, this is generally provided in which instrument? Digital instruments or electronic instruments, we can say. Example, delay unit or delay circuit, we can say. Delay unit in cathode ray oscilloscope. Delay unit in CRO, we can say. Right? Next, fidelity. Guys, what is fidelity? What is fidelity? It is the degree of an instrument to measure any quantity without any dynamic error. Nothing but, if suppose this is the instrument, in this instrument dynamic errors are not there. Assume that in this instrument dynamic errors are not there, then this instrument is said to be having high fidelity. The instrument is said to be having good fidelity, we can say. So that's why fidelity is good. Fidelity is high means dynamic errors are not there, or practically speaking, dynamic errors are very, very less. So this is the total small revision of all characteristics. Now conclusion is, I am writing here only. Now tell me, which are the desirable one? Which are the undesirable one? Guys, desirable means we need higher side. Desirable means we need better side. Undesirable means we need lower side or we need poorer side. Now tell me, which are desirable and which are undesirable? Accuracy, desirable. Precision, desirable. Drift, undesirable, because drift is nothing but deviation. Linearity, desirable. Sensitivity, desirable. Resolution, desirable. Dead time and dead zone must be as small as possible, therefore undesirable. Hysteresis or hysteresis error we can say, that is also undesirable. Here speed of response desirable. Measuring lag itself indicates delay provided, so delay must be as small as possible, undesirable. Fidelity, high fidelity or good fidelity means automatically yes, it is desirable. So this is the simple conclusion of all the characteristics. Right now, sir, here in this corresponding characteristics only one error is there, guaranteed accuracy error. Guaranteed accuracy error. Guys, what is the formula of guaranteed accuracy error? Guaranteed accuracy error is defined with respect to, guaranteed accuracy error is defined with respect to full scale value. Therefore, yes, what is it? AM minus 80 is a static error. That static error is expressed with respect to full scale value. And if you want to get percentage, we'll be multiplying with 100. Now tell me, this is a constant error or variable error? Right? This is a better opportunity to revise the entire subject in a single day. Always remember, if you are preparing, it will take more time. But if you are listening, it will take less time to complete. That's why utilize all these sessions. Right? Now tell me, what is this? It is constant error. It is constant error. Why, sir? AM minus 80 is constant. Full scale value is constant. So automatically constant and constant. So therefore the error will be constant anyway. And based on this topic I told you, in the GATE paper especially, 1 mark model is very popular I told you. What is that? Percentage limiting error is equal to AM minus 80 by 80 into 100. Percentage guaranteed accuracy error is AM minus 80 by full scale value into 100. Both formula we have taken, and relation between these two. Relation between these two. So what is the corresponding relation? If I take 1 by 2, 2 by 1, etc., we are getting percentage limiting error equal to, what is the formula? Full scale value by true value into percentage guaranteed accuracy error. Percentage guaranteed accuracy error. So based on this formula, 1 mark model question is very popular. Either it is electrical paper or instrumentation paper. It is very popular formula. Clear? And after that, we have taken few questions. Before taking questions, sir, for addition and subtraction, which form of errors must be considered? And for multiplication and division operations, which form of errors must be considered? Everyone need to respond for this. Addition and subtraction, which form of errors will be taken? Value form of error, or we can say absolute form of error, no issue. And multiplication and division, which one? Percentage form error. Now tell me, errors must be always added, but I told you one special case is there. Before going to that, errors must be always added either for multiplication or for division or addition or subtraction. Errors must be added. But for addition and subtraction, value form of errors must be added. For multiplication and division, percentage form of errors must be added. Okay, but one special case is there. In the class, I give the complete derivation also, complete mathematical explanation also, to prove that the corresponding thing is a special case. What is that? Parallel connection of resistors. Parallel connection of resistors or parallel connection of inductors. Okay, or we can say series connection of capacitors. In all these cases, if you want to find out R total, if you want to find out L total and you want to find out C total, in that case, what is the technique I gave you? Follow the entire procedure until the last step. In the last step, you need to subtract the errors. Don't add the errors in the last step. That too only when R total is asked by giving the parallel connection. L total is asked in the parallel connection. C total is asked in the series connection. In those cases, follow the normal procedure. Addition, everything, everywhere. But in the last but one step, you need to go for subtraction of errors, not the addition of errors. That's why I gave you this as which case? Which case, guys? This is special case I told you. Clear? Right. So, for idea purpose, let's have a small question. Even the revision series, I'll be taking some questions, right? Now, what is that? For example, I is equal to some number randomly I'm giving 2 plus or minus 0.002 ampere. R is equal to 100 plus or minus 0.0 1 second 100 plus or minus 0.2 ohm, right? Find out power is equal to I square into R. I'm solving, kindly focus. Here, sir, I square into R, so therefore multiplication operation is there. For multiplication operation, what we require? Percentage form, but what we have? Value form. So therefore convert this. 2 plus or minus 0.02 is dash percent of this, so simply 1%. Here 100 plus or minus 0.2 is dash percent of 100, 0.2%. Very simple, over. Now tell me, power is equal to I square R. What is I? 2 plus or minus 1% square. R is 100 plus or minus 0.2%. 100 plus or minus 0.2%. Now 2 square 4 plus or minus, what I told you, if error corresponding square is there, multiply with the power. So therefore you will be getting 2 into 1%, 2%. 100 plus or minus 0.22%. Now, which operation is there? Multiplication. Which form of error we require? Percentage form. Yes, percentage is there. You go for addition directly. 4 into 100, 400 plus or minus 2 and 0.2, 2.2%, so many watts. Otherwise, if they are giving the option in value form, 2.2% of 400, 2.2% of 400, how much? 8.8. Both are correct only. Either option may be in percentage form or in value form, but nowadays MSQ is also there. So both options may be there. If it is MSQ question, you have to select both. Percentage, then convert that into value form, right? So this is all about static and dynamic notation. After that, there are different types of errors. One is gross error. What is gross error? Human being mistakes in observing the reading, noting down the value, that is recording, and then correspondingly calculating the error. So that is gross error. And the second one is systematic error. Second one is systematic error. Guys, in this systematic error, there are three types. One is instrumental error. Instrumental error. What is this instrumental error? Misuse of instrument, that is wrong connection, wrong selection of capacity, or inherent shortcoming of instruments. Inherent shortcoming of instruments, and then loading effect of the corresponding instrument. And then second one is environmental error. Due to the environmental changes, due to the atmospheric changes, we can say yes, error occurred, that is environmental error. And third one is observational error. Observational. What is observation example? The error example is here parallax error. Example for this is parallax error. Right? Next one. The third error is called random error. Third error is random error. This error which cannot be predicted. This error changes randomly. This error varies randomly. That's why simply it is called as random error. Sir, in order to analyze this error, which method we have taken? Gaussian theory, I told you. So therefore, Gauss theory. Gauss law we can say, Gaussian theory we can say. And this Gauss theory follows which law? Law of probability. So therefore, it follows which one? Law of probability. So all these, simply brush up of all these three errors. Now, sir, in this random error, complete mathematical analysis we have taken. What is it? First we have taken mean, x1 plus x2 plus x3 so on by n. After getting the mean, we have taken deviations. What are the deviations? d1, d2, d3 so on dn. x1 minus x bar, x2 minus x bar, like that. xn minus x bar we have taken. And then after this we have taken standard deviation. The formula standard deviation, root of d1 square plus d2 square plus so on dn square by n or n minus 1, both I gave you. And finally, probable error. Standard deviation generally either with S or sigma. Probable error is generally with R, we can say. So already we have taken this mean, deviation, then standard deviation, and then probable error. So this is the simple brush up of the chapter called error analysis. Okay, and before going to the other topic, the point here is, sir, if the errors are given in either standard deviation or random or probable or uncertainty, how the procedure? Did you remember, guys? Root approach I told in the class. So let us solve one question on that. But before going to that, now tell me, everyone need to answer this. I gave this point in the class by keeping the note, by mentioning as very important note. What is that? Percentage limiting error and then random error. Okay, now I am giving just as a match the following model I am giving. Now tell me, among these two, which is maximum uncertainty and which is just uncertainty? Which is maximum uncertainty and which is just uncertainty? Right. Sir, percentage limiting error. Percentage limiting error is maximum uncertainty and random error is uncertainty. Don't forget this. Random error means just uncertainty. Percentage limiting error means maximum uncertainty. Right. Let's have one question on this. At least this time I am expecting answer from many people. Here, voltage is equal to some 100 plus or minus 4%, so many volts. I is equal to 50 plus or minus 3%, so many amperes. Okay. So these errors are probable errors. These errors are probable errors. For example, now find out the corresponding power. Power is equal to V into I. What is the power formula? Power is equal to V into I is equal to 100 into 50. 100 into 50, that is 5000. 100 into 50, 5000. But the error we require, so they have given error in probable error form. We need to represent the error in probable error form only. Probable error form. Therefore, we are supposed to find out probable error. What is that probable error? Simply indicated with R. Probable error in power we require. Probable error in power we require. Right. Correct answer. Root of what is the voltage to the power? 1. What is the voltage error? 4, but percentage keep outside. Take the square, I told you. What is the current to the power? 1. What is the current error? 3%. Outside, take the square. So what is the answer now? 5%. So answer here is, this is the answer. Total power, this is in watts. That's why simply what we can say, direct approach. Direct approach is for which one? Percentage limiting error. Root approach is for which one? Probable error or random error or standard deviation, anything is given. Right? Now, let me take one previous exam question. I is equal to some 12 plus or minus. Otherwise, I'll be changing the value. Just previous question model I'm giving. Voltage is equal to 1 volt, and then standard deviation of voltage is 0.05 ohm. 0.05 volt. Standard deviation of voltage is 0.05 volt. Okay, and then current is 1 milliampere. Standard deviation of current is 0.12 milliampere. 0.12 milliampere. Right? Find out resistance. The two, this is given in NAT model, right? The standard deviation of resistance is dash ohm. He has given like this. The standard deviation of resistance is dash in ohms. They are asking in ohms. Very simple, but there is a chance of writing the wrong answer. Right? The point here is resistance. What is the resistance formula? V by I. Which operation is there? Division. Division means which form we require? Percentage. That's why, sir, 0.05 is dash percent of 1. What is it? 5%. Okay. Here, 0.12 milli is dash percent of 1 milli. So this will be 12%. First you have to convert that. Why, sir? Division operation is there. If the division operation is there, automatically value form must be converted into percentage form. Now, what we require? Standard deviation in resistance. Root of. What is the voltage to the power? 1. What is the voltage error? 5. I told you, keep the percentage outside, whole square. Okay. Plus. What is the I to the power? 1 into. What is the corresponding I error? 12% outside square. So what will be the answer now? This will be 13%, right? After getting this, many people have have given the answer like this is MSQ, no? So they have given like okay 13%. So therefore 13 is the correct answer. Definitely no. Why? He is not asking in percentage, he is asking in ohms. So that is the reason why. What we can write now? R is equal to V by I. What is V by I? 1 by 1 milli. 1 by 1 milli is 1000. So therefore 1000 ohm plus or minus 13%. Now tell me, sir, 13% of 1000. How much? 1000 ohm plus or minus 13% of 1000 is 130 ohm. So therefore, you have to give the answer as 130, not 13. Why, sir? He is asking in terms of ohms. He is not asking in terms of percentage. Clear everyone? If any, what is the numerical answer type questions are there, you should be very much careful whether they are asking in ohms form or they are asking in percentage form. Be clear with that. Then only you can proceed. So what is the answer now, guys? Everyone, 130 is the answer. Of course, 13% is correct answer, but he is not asking in percentage. That's why for this question, what you have to write? 130, 130 ohm. Sir, in this first question, which is the error form they have given? Which is the error form? Probable error form they have given. In which form we require? In which form we need to represent? Same probable error. But in this present question, they have given standard deviation. They have given standard deviation. They are asking which one? Standard deviation only. That I told in the class also. In this type of multiplication, division, addition, subtraction models, if they give in standard deviation, they will be asking you to represent the result in standard deviation only. If they are giving the data in probable error, they will be asking you to represent the result in probable error only. That's why if a standard deviation is given, they are asking standard deviation. We should represent in standard deviation only. Don't convert that into probable or something. Are you clear? When you have to convert means, suppose if the experiment is given like 11.1 volt, 11.2 volt, 11.9 volt, 11.5 volt, 11.6 volt, the data is randomly changing. Then find mean value, find standard deviation value, find probable error value. In that case, you have to convert. But in this case, what he has given? Data is given in standard deviation form and data are answered to be represented in standard deviation only. Don't convert anything. If they are asking in this fashion, then only we need to go for it. Otherwise, what are the form they are giving? We need to represent in the same form. That's what the simple conclusion. Clear, guys? Here, after calculating the standard deviation, in this question, probable error is equal to 0.6745 times of sigma you have to use. You have to calculate probable error, correct? If they are asking like this, then only 100% in this type of thing. By giving something else, they don't ask the answer in something else. Don't worry. Whatever they have given, we need to represent in the same form. Take it for granted. Don't get confused. Clear? Okay. Right? So this is all about the chapter called error analysis. In this shortest time, I could cover all the topics like this. Right. Next one is instruments. Right. Sir, what are the types of instrument? What are the basic instruments we have? What are the basic instruments we have? Generally, two types of instruments. One is primary instruments. These are called as absolute instruments. Primary instruments are absolute instruments. And here, secondary instruments. Guys, primary instruments, what are the examples I gave you? Generally, these are the instruments which are used in the research laboratories, I told. Second way of using, these instruments can be used as reference to design secondary instruments also, we can say. Okay, what are the examples? Remember, tangent galvanometer, tangent galvanometer. Okay, and how many types of secondary instruments are there? There are three types of secondary instruments. One is indicating instruments. One is indicating instruments. Second one is recording instruments, and third one is integrating instruments. Now, sir, what do you mean by indicating instruments? Indicating instruments are the instruments which shows the value at that particular instant. Suppose we are giving 2, it will show 2, ideally speaking. If the 3 is there, it will show 3. If I keep on changing, the pointer value also will be changing. That's why the instrument shows the value at that particular instant. Therefore, this is nothing but simply at the given instant of time, it will show. Suppose value is changed, that will be shown. Some other is changed, some other will be shown. Okay, sir, what are the examples? Ammeter, voltmeter, wattmeter, etc. Okay, sir, what about recording instruments? What about recording instruments? These will be recording all the values in a given period of time or in a given amount of time, we can say. Nothing but simply some sort of graphical representation may be there. So therefore, recording instruments. Examples remembered? ECG I told you. Next, seismograph I told you. And then load flow analyzer. Load flow analyzer, we can say. Like this, so many are there. Okay, right. And oscilloscope also we can say recording, no problem. And integrating. What is this integrating type? It is integration means cumulative summation. It will add all the values over a period of time. Nothing but, suppose in our home, for example, we are paying the electricity bill for 30 days of time approximately. What is that? January 1st into how many number? January 1st, how many number of hours? 10 hours, for example. 10 hours into some power consumption. January 2nd, some few hours into power consumption. Like that, power into time cumulatively added over a period of 30 days, approximately 30 days. So therefore, that entire thing is taken as, what is it? Integration, cumulative summation, or we can say total amount of electricity. Okay, what is the example? Remember, energy meter and then ampere hour meter. Energy meter means watt hour meter, and second device is ampere hour meter or charge meter, we can say. This is a simple idea regarding both instruments. Now, let's talk about indicating instruments. Right. I told you, in the indicating instruments, what are the torques we require? This is 0 to full scale value, for example. The pointer is at 0. Assume this as an ammeter, for example. Right? Now, suppose some current is given, we don't know, some current is given. Okay, that is in the limit only. The moment we give the current, in order to move the pointer, nothing but the current is flowing through the coil, magnetic effect will be there. Therefore, we can say current carrying conductor plays in the magnetic field concept we can take. Thereby, one torque is required. That torque should act in this direction to move the pointer in this one. So therefore, the torque name is deflecting torque. This is a torque which deflects the pointer. I repeat, this is a torque which deflects the pointer from its initial position. The torque name is deflecting torque. It is also called as operating torque, I told you. Okay. So it is keep on moving. assume that here I is there. Whatever the I is given, I is there. Sir, this pointer is getting the force only in one direction, but the pointer is supposed to get stopped. The pointer is supposed to get stopped over here. Now tell me, the pointer is supposed to get stopped over here with which one? With one more force which acts in opposite to the deflecting torque. That torque is called as controlling torque. The controlling torque is a torque which controls the pointer to have the or to stop the pointer about its which position? This position is called as final position. Why, sir? I is given, I is a final position. 3 is given, 3 will be final position. 6 is given, 6 will be final position. In that way, it will be available. Now, sir, as these two torques are almost equal like this, TC is equal to TD, what happens? Pointer is getting force from this side, force from this side. Both are almost equal. Then, before getting stopped, it will be having small oscillations due to its inertia, etc. Therefore, those oscillations should be nullified, should be stopped by one more force called as damping torque. These are the three torques available. Now, sir, deflecting torque by which method? Deflecting torque is by first one, magnetic effect. Magnetic effect. Sir, in this magnetic effect, we have two concepts. One is permanent magnet. With this, which device? PMMC. Permanent magnet moving coil. Second one, electromagnet. But in this again two are there. What is that? One is moving an instrument. Other one is EMMC instrument. All are coming under magnetic only, but one is permanent, other two are electromagnets. The name itself is given as based on the principle PMMC, based on the principle MI and EMMC. Now, guys, tell me, PMMC is applicable only for DC, already we have taken. MI is applicable for both DC and AC. EMMC also applicable for both DC and AC. Clear? Right. Sir, here we can operate this device as an ammeter or voltmeter. Here also, what is it? Ammeter or voltmeter. But here ammeter, voltmeter, wattmeter, and then power factor meter and frequency meter also same principle will be there. Okay, this is one way. Now, second one, electrostatic effect. The device name is given directly. Electrostatic effect. Which device? The name itself is electrostatic voltmeter. Electrostatic instrument, but I gave you this is generally for voltage measurement. Yes, electrostatic voltmeter. Right? Next, third one, induction effect. Induction effect. Guys, in this induction effect, which will be there? Two coils will be there. One aluminum disc will be there based on the induction principle that will be operating. The device name is directly induction type instrument. Induction type instrument. What is the example? Energy measurement, or sometimes power also we can measure, but mostly we prefer energy measurement. So this is all about deflecting torque revision. Okay. Now, so what about the second one? Controlling torque. Guys, remember how many types of controlling torques are there? Controlling torque. Now tell me, how many types of controlling torques or what are those controlling torques? Right? Simply first one, spring control. spring control. Guys, in this spring control, what is the formula we have got? TC is equal to Kc into theta. TC is equal to Kc into theta. If Kc is constant, TC is proportional to theta we have taken. Okay. Next, remember guys, in gravity control method, what was the formula of TC? TC is equal to, we can write, TC is equal to W into L into sine theta. WL sine theta. Anyway, W is a constant. So therefore, what we can say? TC is proportional to. TC is proportional to which one? Sine theta. Okay. So this is the simple idea regarding controlling torque. Okay. Now, how many types of damping torques are there, guys? Tell me. How many types of damping torques are there? How many types of damping torques? 3 types. Air friction damping torque method, fluid friction damping torque method, eddy current damping torque method. There are 3 corresponding torques, that is damping torques we can say. Guys, now tell me, where we use air friction damping torque method, or which device, in which device we use this method? Guys, remember, air friction damping torque method is generally in MI and EMMC in general, and fluid friction damping torque method is generally in electrostatic instrument, generally used in electrostatic instrument. And eddy current damping torque method generally used in PMMC. Of course, even in the energy meter, you follow that eddy current damping torque. Right? Now, in this, guys, tell me, order of preference and order of effectiveness. Now tell me, which is highly preferred? Order wise, you type the answer in the chat box, I'll see. Order of preference, which is highly preferred? Undoubtedly, we prefer eddy. Which is highly effective? Yes, definitely which one? Eddy. Okay. After eddy, which we prefer? Air. Because air is having little bit more advantages compared to fluid in terms of preference point of view. Easy, clean system, simple system, no need to worry about replacing the oil and all, etc. Therefore, air friction is more preferred than fluid. But fluid is stronger or air is stronger? Definitely fluid. Why, sir? Due to high viscosity, the force will be very much effective. So therefore, fluid will be here and air will be here. Clear? So this is the total idea regarding basic instruments. 3 torques are there: deflecting torque, controlling torque, and correspondingly damping torque. Right? Next, let us have PMMC instrument. See, I'm not showing the complete structural diagram and operation, I'm not explaining, because in this shortest time, I need to revise the entire thing. That's why diagrams and operation will not be there. Normal total revision will be there. Sir, PMMC, in this, deflecting torque, controlling torque, and then damping torque. Now tell me, what is the deflecting torque setup in PMMC? Like that, all the 3 devices I'm writing together so that you can have all 3 devices revision. Tell me, what is the deflecting torque setup in PMMC? One permanent magnet and one coil. Okay. In MI, one coil and one iron vein, we can say, small iron piece, we can say. Iron vein or iron piece. Okay. Next. In this EMMC, two coils will be there. Okay. Now, which type of controlling torque? In general, we prefer which one? Spring control. Here also spring control. Here also which one? Spring control. Okay. Now, everyone tell me, just now I told you in the corresponding application point of view, PMMC, which damping? AD. Okay. MI, air friction. EMMC also air friction. So this is a simple constructional model of all the three. Now, guys, in all the three, spring control method is there. Means what is the formula? TC equal to KC theta only. Sir, TC is equal to KC into theta. TC is equal to KC into theta. TC is equal to KC into theta. Because everywhere spring control only. But did you remember, guys, what is the deflecting torque formula in three cases? We have taken complete mathematical derivation for all. Here we have taken F is equal to BIL, sin theta taken as 1. After that multiplied with N and then multiplied with width. Therefore, BIN into A. TD is equal to BIN into A. Right, at least for this one, tell me. Moving iron instrument. Moving iron instrument. BVNA by R. So you are saying that BV by R is IN. This is the formula for which one, ma Pallavi? PMMC. Already gave you. PMMC over. Yes, you are right. But this is for PMMC. Already gave you. I am asking for MI. What is the formula? Half I square DL by D theta. There, TD, I square dm by d theta. I square dm by d theta. Okay, right. After that, continuation I am giving. PMMC, MI, EMMC. Okay, right. Sir, everywhere or in every instrument at final position, TC equal to TD, right? So therefore, TC is equal to TD. TC is equal to TD. Yes, TC is equal to TD everywhere. That is a common one. Now tell me, what is TC? KC theta BIN into A, or as you said, BVNA by R. V by R is I, no problem. Here, KC into theta half I square DL by D theta. Okay, and here KC into theta, here I square dm by d theta. Now, finally, what we can write now? Theta formula. Theta is equal to BIN into A by KC. BIN into A by KC. Here, theta is equal to, what is the formula? Half I square by KC DL by d theta. Half I square by KC DL by d theta. Here, theta equal to I square by KC dm by d theta. half I square by kc dm by d theta. If you follow these three formula, yes, 1 mark or 2 mark model questions will be there. Okay, right. Sir, PMMC is applicable only for DC. What does it mean? What does it mean? DC means it is not giving the meaning like we should not give AC. No. Even if you give AC means what we require? RMS value, but it will not give RMS value. It will not give RMS value. That is the reason why you need to understand that DC means, yes, it reads average value. Even though we give AC supply, it reads average only. That's why we don't prefer. Why, sir? AC means RMS we require. But here this is applicable for DC as well as AC. It is also applicable for DC as well as AC. Guys, DC means average value, RMS, nothing but we can measure both. If you give DC, it will give average. If you give AC, it gives RMS. Same thing here also. Yes, both are possible. Both are possible. Right. Now, sir, here current and voltage we can measure. Current and voltage we can measure with this. Current, voltage, power, after that frequency meter also same principle, power factor meter also same principle. So IVP, all these are the corresponding simple revision of all the three instruments. Guys, is this clear? All three instruments together I gave you. Is this clear? Kindly respond. All three instruments revision. Okay, now let's have one question, universal question related to all instruments I'm giving. I of t is equal to -6 plus or minus 8 root 2 sine 314t amperes. This is given to first device PMMC. What is the reading? Second device center 0 PMMC. So what is the corresponding value? Right. Next, MI instrument. What is the reading? EMMC instrument. What is the reading? And I told you these are safe side I'm giving. What is it? True RMS meter. What is the reading? Finally, hot wire instrument. What is the reading? Now, take 2 minutes of time and tell me. 6 plus or minus 8 root 2 sine 314t is given. So kindly focus. PMMC reads average value. Let us find out average value first. Average value of this is -6 plus average value of this is 0. Therefore, -6 amperes is the average. But he is not asking us to find out the average. He is asking us to find out reading of PMMC. Now tell me, this is a PMMC instrument. This is 0. This is full scale value of the device. Like this. Okay. Now tell me, which current we are giving indirectly? -6. Sir, below 0, do we have any scale for this? No. As there is no scale below 0, automatically, does it move below 0? No way. Therefore, reading is which one? 0 ampere. Very, very important. I am not saying that average value is 0. No. Average value of the given supply is -6 only. -6 means current is flowing in the reverse way. Means reverse current is flowing, or current is flowing in reverse way. Therefore, torque produced in the reverse way. Therefore, the pointer gets the TD in this direction. But do we have any movement in this? No. Why, sir? Below 0 there is no space, there is no scale. Therefore, the pointer reads 0. That's why I'm writing clearly average value -6 only, but reading of the instrument is 0. Now, same statement, but different way. What is it? Same input. Center 0 PMMC. Yes. What is average value? -6. But which type of device it is? Not the normal PMMC. It is which device? Center 0. This side full scale value. This side is also full scale value. Okay, now tell me. Sir, average value is -6. Indirectly we can say reverse torque. Torque produced in the reverse way. Yes, if the torque is produced in the reverse way, do we have any space below 0? Yes, we have the space below 0. So automatically it will move this side. Therefore, what is the answer? Reading is how much? -6 ampere. Reading is -6 ampere. Here reading is 0 and here reading is -6 ampere. Okay, now next one. MI instrument, moving iron instrument. Sir, in this moving iron instrument reads which value? RMS. So therefore, we need to find out RMS value of the given supply. Now tell me, it is corresponding constant portion and sinusoidal portion. Both are there. I am using the word, it is a constant portion, it is a sinusoidal portion, both are there. What is the RMS value of the given equation? Means root of constant portion square -6 square plus what is this? Im sin omega t model. So Im 8 root 2 is there, Im by root 2 whole square. So therefore 8 root 2 by root 2 whole square. So what is the answer now? This value will be 10 ampere. So this is one answer. MI instrument reading is 10. Sir, EMMC also applicable for AC. EMMC also applicable for AC. AC it reads RMS value. Therefore, EMMC reading is also RMS. Therefore, 10 ampere. Guys, RMS is 10, reading is 10. RMS is 10, reading is also, because it reads RMS value. The name itself indicates a true RMS. The name itself indicates true RMS meter. Therefore, it is also reading RMS value. Therefore, directly 10 ampere. Okay, now hot wire instrument. Guys, as it is hot, the question is, it is with respect to heating concept, thermocouple type of concept. Hot wire instrument, it also applicable for AC. So therefore, it also reads which value? RMS value. Therefore, it is also giving the reading of 10 ampere. So what is the answer now? The options may be like this: 0, -6, 10, 10 and 10. Why? First answer is 0, second answer is -6, third is 10, fourth is 10, fifth is 10. Of course, sixth is also 10. Like this, the options may be there: 0, -6, all are 10. So this is the complete answer regarding all instruments. Clear? Right. In one of the previous papers, just I am giving the model explanation. Sir, PMMC data is given. Some PMMC data is given. Okay. What is the data? For example, B is given, right? Number of turns are given, and then area of cross section, but coil length, width are given. Okay. And then EMMC. Okay. In this, right, correspondingly, dm by d theta is given. For example, like this data is some value. I'm not taking the value because they may be changing the value, but I'm giving the concept. B is given, N is given, A is given. dm by d theta is given. Okay, right. Now, in both the cases, what condition they have given, the Kc of PMMC and Kc of EMMC both are same. Kc of PMMC and Kc of EMMC both are same. And angle of deflection produced in PMMC instrument is equal to angle of deflection produced in EMMC. Both are same. What is it? Spring constant in both the instrument is same, and angle of deflection produced by the two instrument is same with some value x, y, z, some other values will be given. Now they are asking find out the current value. It is a previous question, but I am not giving the values, I am giving the complete concept. Now tell me, how do you find out the I value? This question is given almost 10 to 12 lines of question, 10 to 12 lines of data. Just by looking 10 to 12 lines of data, first thing is we don't start it. Because lengthy data, time consuming, it may be a tough, we think in that way. Don't do that. Kindly go through the entire question clearly. Answer or solution will be very simple sometimes. This example, lengthy data will be given. But what is the procedure? How to conclude or how to calculate the current means? Sir, in the solution, what you have to do? Sir, theta of PMMC and theta of EMMC, both are same. So therefore, let me write that theta of PMMC, theta of EMMC, both are same. Who is given? This is given in the data itself. This is also given the data itself. He is asking us to find out I. Okay. Now, what is theta formula in PMMC? B I N into A by Kc. B I N into A by Kc is equal to theta of EMMC, I square by Kc dm by d theta. If you are able to understand this thing will be done. That's why I already told in the class many times, read the question carefully. If you read the question carefully, no need to go back, no need to come forward, go back not required. Simply go through each and every word clearly, then it will save your time. Okay. Now tell me, which are same? Kc. Okay. And here, one I will be cancelled. So what we require finally? I value. Therefore, I is equal to B into N into A by dm by d theta. Now check it. B is given, N is given, A is given, dm by d theta. B N A dm theta. Calculate the current like this. Don't get confused by looking at the lengthy data question. Answer is very simple if you understand the keyword. What is the keyword? These two are the keywords. He has given same spring constant and he has given same angular deflection. So therefore, this is a keyword. If you observe this, you can have the current value properly. This is I equal to B N A by dm by d theta. Clear? In this way, we can calculate. So this is the total revision of which one? Corresponding three instruments, PMMC, MI and EMMC. Now, the point here is, this true RMS meter gives the actual RMS value. That I will try to cover that point also in this today's session. Right? That what is that? Rectifier type instrument is there one. In the rectifier type instrument, what we measure and how do we convert RMS value? And a true RMS meter, no need to convert. That's why it is simply taken as true RMS meter, etc. Don't worry, I'll give that also. I'll revise that point. Don't worry, who is this? Abdul Alim. I will explain that later in this today's session. No need to worry. What is the meaning of true? Why that is given? I'll give you. Okay? Is it okay? I'll explain. Once I complete this electrical part, just brush up. I'll be taking the electronics part also. Then we'll be having complete revision. No issue. Sir, in this, for see PMMC generally preferred or applicable for DC. Preferred also DC? Yes, DC. For current measurement, for voltage measurement, preferred. Okay. Now tell me, MI instrument applicable for both DC and AC. But are you ready to prefer MI for DC? Everyone need to answer. Are you ready to prefer MI for DC? This MI is preferred for which one? AC only. I'm not saying that. Don't take it in the negative way. Don't take it in the wrong way. MI cannot be used for DC. I'm not saying that. I'm not saying that. MI is not preferred for DC. Cannot be used for DC. I'm not saying. I'm saying that you can use it for both, but preference is for AC. Comparatively, it has little bit more errors. Therefore, less error device is ready for DC. We prefer that. So we go for AC. That's what the meaning. Okay, and that so many are there. No, PMMC has high torque to the weight ratio compared to MI. Therefore, frictional errors are less, frictional errors are more. In that way, we can say yes, PMMC is better for DC. If that is the case, you are right. But I'm asking preference. Okay, right. Next one, EMMC. Applicable for DC, applicable for AC, used for measurement of current, voltage and power. But preferences. EMMC is preferred for which one? You can use it for current, you can use it for voltage, you can use it for power, okay. But preference, right? We can go for DC power as well as AC power. Nothing but we prefer EMMC generally for which one? Preference point of view. That's why in this case, tick mark indicates what I told you in the class, preferred. Tick mark indicates preferred. It doesn't mean that for other thing you cannot use. No, you can use it, but preferences for that's why in your machines laboratory, in your 4 years of engineering, DC machines laboratory, PMMC you used for current and voltage, EMMC that is a dynamometer we say, EMMC other name is which one? Dynamometer, wattmeter. So DC wattmeter used. In your AC machines lab, you used MI instrument for current and voltage in the AC machines lab and AC wattmeter used. That's why dynamometer, DC or AC. PMMC for DC. MI is applicable for DC, AC. EMMC is also applicable for DC, AC. Here current and voltage, current voltage power. This is applicable. But which you prefer more? Preference means what? Whichever is giving the less error, that we prefer. Whichever gives a less error, that we prefer in general. That's why, sir, PMMC, less errors, so we prefer. MI, little bit more errors than that. That's why for DC we don't prefer, AC we prefer. That's what the meaning. And EMMC, current and voltage DC, this is better. Current and voltage AC, this is better. Therefore, we prefer for power. That is what the meaning. Preference means whichever gives a less error, we prefer more. That's what the meaning. So therefore, the preference point of view, this one, but I'm giving clearly the tick mark indicates, preferred. Using means you can use other case. What is that? You can use it for DC, you can use it for current and voltage also, but preference point of view is this.